All right, welcome back everybody. Today we're going to be working on a lesson to create two new models. Our first model that we're going to be working on today is going to be a model that focuses on how light interacts with our cup system. So we're going to talk about that model first. So we're going to be drawing our model today on this template. So we're going to start by making a picture of a cup here. Nice thing about Notability is if you hold the line, it makes a nice straight line, so you can draw a nice picture. I'm going to put my straw in here. Alright, that's kind of the basic outline of our model. So what we're going to try to do in this model is we're going to be trying to think about how does light interact with our cup system. So the first thing you have to think about is where is the light coming from that is going to interact with our cup system. So you have a couple options. It kind of depends on where your cup is at. If we were doing this experiment in our classroom, the cup would just be sitting in our classroom and the light would be coming from the lights on the ceiling. Okay. Another scenario might be if this cup was sitting outside on a picnic table, the light might be coming from the sun. Okay, so for this scenario, we're going to say that the light is coming from the lights in our classroom. So we're going to maybe just draw a light in here. Okay, so here's our light. And we know that the light's going to kind of travel in all directions. So the light's going to go through the lid. Or is it going to go through the lid? Okay, there's going to be light coming from kind of around the cup in all directions. So the first thing you have to think about is, well, what is this light going to do? Is it going to travel through the cup? Like, for example, if this light wave, would it go all the way through the cup and out the cup? Or would the light travel to the cup and then bounce off? One other thing that might happen, or would the light go through the cup and then maybe bounce off the inside layer of the plastic and kind of get trapped in the cup? So the first thing I want you to think about in your model is, what is the light going to do? Is it going to pass straight through the cup? Is it going to hit the cup and reflect off? Or is it going to pass through the cup and kind of get trapped because of the plastic? So the next thing we have to think about, well, how is that light going to interact with the water that's in the cup? So we're going to put some water in our cup here. And we also know that we have water molecules in our cup. So I'm going to put some of those in. And it's a liquid, so the water molecules are going to be fairly close together. So what we need to think about is, how is this light going to interact with these water molecules? So there's light going through the cup right here. Is it even going to interact with the water molecules? So we have to think back to our last unit. We learned about solids, liquids, and gases. How does the energy affect the speed of the water molecules? We learned that the more energy we have, the molecules are going to travel faster. The less energy we have, the molecules are going to travel slower. So if you believe that the light is going to influence the water molecules, maybe it's going to make them move faster, then maybe you should put some arrows in here that are showing that that light is going to help move those water molecules. And you can include labels, like you can type in here, you can say light transfers energy to water molecules. And you can kind of just move that over here, place where you can see it. Put it down here a little bit. So feel free to label and explain what is going on in your model. If you don't think that's the case, maybe you think that, like we talked about earlier, maybe the light just kind of goes straight through the cup and it doesn't really have any influence on it. Well, then you could label that. You could put a label here that says light goes right through the plastic and doesn't really change the temperature or the heat. So again, this model is trying to show us how does the light influence the cup system? Does it change the temperature of the liquid in the cup, or doesn't it? So I want you to put down your initial ideas. All right, our second model is going to be about how does heat or cold influence our cup system. So I'm going to draw another cup here. Make this one a little narrower so we have more space. Put my lid on here, straw. All right, but this time we're not concerned about the light, but we're concerned about how does heat or cold affect the liquid in the cup. Remember, our cup is going to be full of cold water, about 6 degrees Celsius, which is, a little bit above freezing. So it's pretty cold water. So we know we have a lot of coldness, I guess you could say, inside the cup. We also know that we have water molecules inside the cup again, and they're pretty cold. They're not freezing, but they're going to be pretty close together. So in this model, I want us to focus on just what is happening between the liquid inside the cup and the heat that is potentially outside the cup. So we have to think about, well, where is that heat coming from that's outside the cup? So we know that around the cup we have air. Okay, so we can assume that air is a gas. We're going to put some air molecules outside our cup, and they're gas, so they should be spread kind of further apart. So the next thing you have to think about in your model, does this warmer air, right, the air is going to take on the temperature of the room, so it's maybe about 70 degrees depending on the room you're in. So you have to think about, does this air that is outside the cup, this air right here, does this interact with the water molecules? And your model should show that. So you either would think somehow that these air molecules would interact with them. Maybe somehow they're going to transfer some of their energy through the plastic, or maybe you don't believe that. Maybe this plastic is going to take that heat and just cause it to bounce backwards. So I want you to put what you think is going on and just focus in on how are heat and cold being transferred in and out of the cup, if you think they are. Maybe they aren't. And how are heat and cold affecting the temperature inside the cup? So those are our two models. When you finish the two models, I want you to make a claim, and a claim is what we think based on the information. So we're going to make two claims. Our first claim is going to be about our model for how light interacts with the cup, and it says this makes the temperature change because. So do you think the light is going to change the temperature in our cup? And you're going to say yes or no, and why? Why do you think the light is going to change the temperature? Or why do you think it's not going to change the temperature, okay? Then do the same thing for this claim. It says this makes the temperature change because. So we're talking about, do you think heat is going to be transferred in and out of the cup? And is that going to change the temperature of the liquid in our cup? Okay, so I'm looking for a complete sentence for that. So this model is going to help us prepare for the investigation we're going to be doing later this week. We are going to be doing another virtual investigation. We're going to be setting up a heat lamp and trying to see if light actually does affect the temperature of a whole bunch of different cup systems. We're going to have metal cups, we're going to have cups with lids, cups without lids, and we're going to collect a whole bunch of data, and we're going to try to figure out this problem. So this model is kind of a starting point. So good luck with this. Do a good job on it. Take your time, and we'll see you next time.